I'd like to make it more discussion-oriented. I have a few slides, but I'll pause. Feel free to ask me any questions anytime. Um, so essentially, this is all about K8s, especially applying for it for edge computing, and also how it correlates to the work we are doing in Onap. And I'd like to thank especially Srini from Intel and also Ravi for helping me leverage their joint presentation at ONS on Kubernetes for Edge and NFV. With that, let's get started. So agenda-wise, we'll talk a little bit about the transformation journey towards all K8s, how things are happening. And we, in fact, had a very interesting panel at ONS with Vodafone, AT&T, and of course, Intel, and also notably Amdocs and Bell Canada, where especially operators are in their transformation to all K8s. We'll talk about it. And also, as a starting point, how applications are being rethought, right? The transformation from centralized in a particular data center, which is essentially your public cloud or private cloud, to essentially completely distributed, where some parts of the applications on the edge and some parts in the private or public cloud. Then we also talk about, with that, the role of a multi-cluster, completely K8s-based orchestration solution. Then we'll also talk about how multi-cluster service mesh plays a role in, connecting the dots. And we'll take a 5G core application example and how it maps out, the service-based interfaces and how it maps out to this architecture. Then also look at community efforts, ONAP and Akrino, what is happening in this space. Excellent. So towards K8s, how did we start there, right? So we all started with essentially, when Kubernetes came on board a couple of years back, it was all around almost two separate ecosystems. One is your non-K8s VIM, Virtual Infrastructure Manager. So basically, essentially two of these resource orchestrators which coexist, where essentially at that point in time, K8s and CNFs were, especially the cloud native, it is not really cloud native network functions, it's just out of pure container network functions. And that is what was running on Kubernetes, and Kubernetes was also used for other microservices, application microservices. But all the heavy-duty real deployments network functions were all on non-K8s VIMs, which includes open source OpenStack or VMware or Azure Stack or any of these, right? Or even Wind River Titanium. This is really where the journey started, but really two different resource orchestrators. And sometimes there was one common network interconnect fabric between those. I have a practical example. We used to use NSXT. We still use in such a deployment. But in some cases, there's probably not even a common network fabric. These two are completely separate deployments. With that starting point, it slowly evolved to essentially one resource orchestrator, right? Essentially, the non-K8s VIM could be OpenStack or anything. But what is interesting is K8s is really running on a set of VMs here, right? And there could be multiple K8s clusters, right? This is the next transformation in the journey. So at least deployment converged to one resource orchestrator, but essentially Kubernetes running on a set of VMs which are managed by that resource orchestrator. And of course, in this model, since Kubernetes is running on a set of VMs, these two Kubernetes clusters have strict multi-tenancy. Right? Within a single Kubernetes cluster, you can use namespaces and other, other isolation techniques, the soft isolation techniques. So from there, the last leg in the ultimate transformation is all Kubernetes running on bare metal, right? Where all workloads, VNFs, CNFs, and at this point we expect it is not container network function, it's actually a cloud native network function written in 12-factor style. Really using all the native the coolness of the cloud native ecosystem. And of course, microservices all running on a bare metal Kubernetes deployment, right? And the interesting part we're seeing here is even with all this, there is often a need for especially strict VM-based multi-tenancy. Then we'll go back to the previous model and leverage it. Basically, the brilliant part about Kubernetes is not just about containers or microservices. It can also manage VMs, right? KubeVirt or Virtlet or so many other efforts. There are other VMware efforts. So on those VMs, you can create a set of several Kubernetes clusters and deliver strict multi-tenancy. So it's the best of all worlds, Kubernetes on bare metal with Kubernetes running on Kubernetes if you desire strict multi-tenancy. So any questions on this? And in fact, we had a very nice panel with Vodafone and AT&T. It seemed like AT&T is way more advanced. In fact, there's so much in OpenStack a couple of years back, but now they're actually ready to fully jump into the last leg of the journey. Whereas Vodafone, at least what we heard there, was a little slow to transformation, especially given the unions and the European stuff going on. Questions on this? I'll pause for a few seconds. Excellent. Okay. So with that introduction, so it's all Kubernetes. That's where we're all heading. So what is this application transformation, right? So so far, when you go to any standard enterprise deployment, right, what happens is you always talk about north-south traffic and east-west traffic. That's what you talk about, right? Basically, even when you bring edge, you say, hey, there is some local traffic which is east-west, or a private cloud, there is some local traffic, and then there is north-south across these clouds, edge cloud and private cloud or public cloud. But if you look at an application transformation, it's getting truly distributed. A specific example which comes repeatedly over and over again is distributed analytics. In fact, essentially there what happens is you have the analytics inference components running in the edge here, right? And then your learning or training component is running in the cloud. So that's how the distribution is. So it's a single app truly distributed across different locations. And that's exactly the way to go if you want to capitalize on edge, right? So basically, and this app, you should be able to move around. For example, if you're tying analytics to an AR, VR application, right? And as the end user moves around, you want to perform some video analytics right at the location where your data is, right? So that means then it's also sort of quasi-mobile, right? The application moves with where the user moves. And in this transformation, so basically what we see is application has different microservices. Some microservices, especially learning or inferencing component, the inferencing component is running on the edge, whereas the training component is running on the cloud. So anything which is more user-facing, latency sensitive, right? All those running at the edge versus the non-latency sensitive part running in the cloud. But the key is that all of these are part of the same application, where we really don't want to have this distinction of east-west or north-south. It's just a distributed application, with certain characteristics, and we want to have your application placement policies around that, and try not to couple yourself to this old east-west and north-south paradigm. And the interesting part is, I mentioned the analytics example. So basically, this concept applies to any application. It could be a managed application or a management application. And that's where sort of it gets very interesting for an orchestrator like Onap, or this is true for other orchestrators too. So basically what we are saying is, hey, you have some managed workloads, which are really end-user applications. Consider a AR, VR application, right? Cloud AR, VR application. So there are certain components which are in the edge and certain components in the cloud. And you're doing all this effort in orchestrating them. And now, so to deliver this application, you have certain components of the overall orchestration solution, which you call the management components. And what we are saying is, once you have this framework, then you can leverage it to also place those relevant applications. For example, if you're doing closed loop, then you will say, hey, these are the specific edge locations where I need to place my closed loop components. And I can use the same framework to manage those. So we'll talk about how it's being done, but in essence, the same paradigm holds for managed applications. A good example is cloud gaming or cloud AR, VR, versus the management applications, which are actually helping deliver an end-to-end service, such as analytics or closed loop. Any questions on this?
If it is an enterprise or group of enterprises under one company, corporation, how is corporate data governance is done using when these microservices are running? Because data governance, corporate data governance is a different function from operational functions. Data quality, data cleansing, data security, etc., has to be done based on the corporate level strategy, which translates into strategy to procedures and processes, etc., in terms of managing from top to bottom and bottom to top percolation to have sanctity in the data that is required, which includes security.
Absolutely. Very good question on security and data governance. So we'll talk about sort of how it's done, but in short summary, essentially, so the question was on data governance specifically, right, and how that is being being looked at, right? When we are talking here about, I gave some examples on cloud AR, VR, and all those. So there are certain data governance policies. So how do you actually realize them, right? Or is it taken into account?
And that has to be derived from the corporate governance strategy. One of the governance strategy is for security, data cleansing, data how warm or cold is it for various applications. And from that, automatically, an ideal corporation should go down and be used in various levels, and then the results are percolated up to validate, at the strategy level. That's what indeed implemented. And this is true even for a cloud. A cloud is itself an enterprise by itself. Our cloud instance that's used by an enterprise is itself a data governance boundary or expanse that has to be monitored, everything.
No, absolutely. Great question again. So basically, while we talked in the examples at length about, for example, bandwidth and latency, which are probably more service impactful, to your point, definitely these are all like key operator, service provider impactful decisions where the data should be, where that it should not be, rather, correct? And
the holistic perspective is not provided by the microservices.
So it sort of will look at the orchestration example. So basically, there's some part which is there are different levels in the orchestration. We call it resource orchestration versus application orchestration. the resource orchestration will go through some of the examples and how it helps you deliver this.
Okay, we can discuss after.
Yeah. Perfect. Thanks for setting the stage for that. With that, I'll move to this one. Yeah, exactly. So we talked about a distributed application. So now, essentially, we're talking about how to deliver this, right? So we have this nice distributed application, but then there is no real value if we cannot orchestrate across these distributed clouds where there are several edge locations. And of course, it's not just about edge, because this I feel essentially this happening over and over again. In fact, I don't want to speak bad of HCMech, but essentially the point of view they're driving is there are some applications which run on the edge, they call it mech platform, but they think that's what they run, that's it. It's like the entire application is here, but that's not really true. The moment you're talking mech or edge, it's actually truly a distributed application where some components are running in the edge, some could be in private or public cloud. So with that said, essentially, the point you raised about data governance, GDPR, those are all policies which are enforced as part of the application orchestration. There are two levels. One is a resource level itself. So basically, these almost come at the resource level. So basically, hey, though there is capacity available, I can essentially have my data stored, for example, my video stored only in a specific location, right? And based on these policies, I will store at that location, correct? I cannot store, I can only cache data at the edge for example, maybe 24 hours. That's my policy as an example. So those policies are all executed at the resource orchestration level. And so at the application level, you're just thinking of microservices and then submit it, right, and you're done. Basically, all you have is a set of SLAs, right? So basically say, hey, I want to deliver AR, VR. I have an AR, VR application. I need 20 millisecond application response time. That's my application SLA, right? So now you go help me realize it. And the operator may choose to, in fact, with all the complex orchestration policies, may come back and say, for meeting the needs of the customer and based on my capacity constraint, may choose to do even the learning component of the edge. The application doesn't care or should not care. Right. This is very different. This paradigm is very different from the north, south, east, west paradigm, where sort of the application is too closely coupled to the infrastructure. Like it's like hard decouple. Suddenly, like, oh, I need to know like where exactly I am. And then all your security is applied typically for north, south, and east, west. Of course, you have some security, but it's more of the micro segmentation level, L4 level. So basically, here the idea is you completely get away from this north-south network-centric view to an app-centric view. Basically, you're talking application and SLAs, and you have infrastructure policies, which include security, data governance, and everything. And then our goal is to the multi-cluster K8s orchestrator deliver those. And our biggest focus is on the infrastructure front, right? Whereas the application CI/CD is a little higher level for us. But these will help deliver the application SLAs. And also, one of the things when we see is like when new edges come up, it should all be seamless, right? Without any manual intervention. We don't want to, again, like, hey, click through 20 commands for setting up a new edge. It should all be automatic, right? It should be as good as, hey, one click, an edge is ready for you, right, to use. Because edges are so dynamic. For example, there is a stadium event and you want to set up an edge just the day before, and you can't be running like commands and checking through, right? It doesn't cut it. And other thing we see is it's not just about, we talked at length about application microservices, but the other important component is also the relevant network functions. For example, if you go to edge use case, you always have the SD-WAN as a key component. Right? You need to connect to the cloud in some form. So basically, this also means that the relevant network functions will already be rightfully instantiated, the right edge location. as you instantiate the applications. And we see interesting variations. The world is fully not there in cloud native network function. I always would like to use the word cloud native. And in some cases, it's still containerized. I mean, basically, it's not fully cloud native. And in some cases, it's not even that, it's still VNFs. But our goal is to sort of support all this through Kubernetes, VNFs, container network function to the true cloud native, coupled with the application. That's the goal. It's not just about delivering the application, because that doesn't, basically you've just delivered an application. What about the network connectivity? That's also a key part to delivering an end-to-end service. Excellent. Any questions on this?
And the microservices have some very specific, special function to accomplish, right? And they are spawned one after the other, even though they are kind of identical to each other. They have a task to do that does it and disappears. There's one more microservice, but that whole orchestration is what I'm concerned about, rather than microservices.
Exactly.
It's good for RPA applications, right? This is all good for RPA applications, but there'll be an RPA strategy that has to be developed. When and what and where.
Correct.
How many microservices are you spawning? Okay, is it too many, too little? And
exactly.
How do you know that it is completely implemented?
Exactly. Very good point. Again, this ties very much with the famous resource constraint edges, right? So basically, you have often just 3 nodes in a single cluster. It's a very common. The small edge, if you walk into a Target store or Macy's, that's what you get, right? Or the telco far edge, right? If you're coupling with RAN, that's what you're going to get. So resources are absolutely premium. So that means you have to make sure microservices live exactly the time they have to be, and after that, they're scheduled out. And then whatever else which is helping you make money should be there, or do anything else. So with that, so again, what I want to stress here is, well, you talked about at length about the managed workload themselves. What we see is, again, the consistent paradigm, where this is absolutely applicable for the management workloads too, right? We talked about a dynamic edge before. So we'll talk about the service mesh example here. What it also means, like setting up the right control plane components dynamically. It's a very critical piece. All the coolness we talked about will not be possible without having the right control plane components, which could also mean even installing the right monitoring components such as Prometheus. And all these are also very dynamic, by the way. We should not assume that it's like a static world, it's all pre-deployed. I mean, it's not going to be as dynamic, definitely, as the managed workloads or application themselves, but it's much more dynamic than, hey, these are all instantiated once and don't bother, right? That's the key point here. And once we do this right, the multi-cluster K8s orchestration, it can be used for both, right? Basically, instantiating the management components first, but of course, their LCM will be much longer lifetime, and then the relevant, and use them to deliver the application microservices and the necessary network functions. And this is sort of the coupling we are doing in Onap, making sure that both are happening. It's not just about the applications themselves and figuring out, hey, oh my God, I need to install all my monitoring components. Okay, you go figure out a way to do it, but use the same framework to take care of that too. So basically, applied for management and managed workloads. And with that, I would like to go to the popular service mesh topic. At least we feel this is the key component of the overall solution, and how it ties together to the overall multi-cluster orchestration. So we talked about the workload orchestration part, specifically the service mesh solves a very interesting problem around traffic orchestration, which means essentially you're delivering a thank you, CI/CD pipeline, and then also that means like traffic routing on demand, introducing new apps, and then self-healing, so many benefits, right? And one of the key things is often, so whenever people talk about service mesh, they always talk about a single cluster service mesh. Everything great. I mean, you know, I understand I can deliver this, that, like, you know, all the great things, right? Because my your sidecar, right, which does your security and your traffic management is completely isolated from your application, and I can deliver seamless security and everything at ease. But now the interesting problem is, the moment you step into the really truly distributed application, it's not about a single K8s cluster. It's really multiple K8s clusters you're talking about. And this is sort of where I think a key area we're focusing on, how to couple the service meshes across different clusters. Some of the key challenges we are solving is, K8s is great within a single cluster. The moment you want two K8s clusters talking, then how do you go about it? It's not trivial, right? There's no direct answer. What we see is like essentially through the service mesh, ingress, egress gateways, our goal is to do automatic NAT, right? And that we see that working consistently for all layer 7 application without any problem, right? And that way, you know, when you're connecting distributed applications across multiple K8s clusters, it's seamless. It's a no-brainer. It's not like you need to do 10 things to make it happen. So today, by the way, there is no automated way of doing this, and that's exactly the problem we want to solve, but solve it first for the layer 7 case, right? And it solves the application connectivity. Of course, layer 4 is a little bit tricks involved, layer 2 to 4, but layer 7 is a common case when you want to solve it first. And we feel NAT is probably the best and easy approach, because consider a sort of a multi-vendor environment. You have no control over what IP address is allocated, right? You know, all of them may be using 10 or 20, you have no idea, and NAT works consistently all the time. About IPv6? We do think about, so here is one interesting challenge we found. When we did the survey, not all K8s deployments have IPv6 enabled by default. Exactly. So when we get to that point, of course, we said yes, we need to turn it on. It helps in basically probably in end-to-end visibility. But given where the deployments are right now, it's all IPv4 standard. I mean, of course, I'm not saying people don't use IPv6, but it doesn't seem to be the de facto. Excellent. Any questions on this? So one highlight here I want to bring about is when we did this, we cannot just say, hey, okay, I'm going to just install Istio control plane on every edge K8. It's just going to not work. So you're probably looking at often combining a few edge clusters and then having an Istio control plane. Then you have to make sure that all your bandwidth and latency requirements are met. So, and these are things which are working out, and you know, seeing what are the best practices towards achieving this. It's another level of complexity we're talking about.
And let me just inject one more thought here. There are multi-cloud management is being looked at by some companies at least, where you don't depend on one cloud. Then how does that block that you have cloud platform, in addition to the edge platform, how does it transform in a multi-cloud environment?
Very good question. At least what we are thinking is, we are assuming the baseline as K8s. At least we want to pick one target which is easily solvable. So if you walk into Amazon, we have EKS, it's just K8s. So basically, we want to make sure first, anywhere where it's K8s, the problem is solved. That seems an easy target. To your point, then we'll also get to the more complex cases of true multi-cloud. For example, even Istio service mesh, it's not just about interconnecting containers. It can even connect, GCP VMs or VMware VMs or Azure VMs. So that sort of will bring in next, we were thinking, yeah, as we progress. But going all K8s seems an easy target for us. Solve the easy common problem first and get to the other one. And with that, so I'd like to hit upon a popular example, 5G core architecture, and also tease up how service mesh can help. So as you can see, right, in the top, you have the 5G core control plane, right? And sort of you have the key 5G core data plane component, right, your UPF, right? And then you have the UE, the end user, and the RAN components, right? And you connect to the external data network, right? This is your 5G core architecture. What we see is very interesting. So basically, what we said was, let's see where we can use service mesh, right, in this whole architecture. What we are seeing is a 5G core control plane is the sweet spot for service mesh because it's completely HTTP based, right? All these interfaces, NMSF, NMF, all are all, HTTP 2.0, So what we are realizing is that's an excellent starting point for applying service mesh, right? So rather than looking at the data plane, of course, it's all more layer 2, 4 centric, right? And then it is not amenable for L7 service mesh. So we'll wait on it, don't bother, right? But we feel that the 5G core control plane, SBA, look at this, and SBA, the whole service-based interfaces in the control plane are all HTTP 2.0 based, right? And that's our initial target. So, and what we want to do is take this as a concrete example. I've been talking to folks like Ericsson and Nokia, and they also agree that this is a great starting point. Start somewhere meaningful, and then bring your service mesh, and then make progress and see how we can sort of integrate your more layer 2, 4 data plane centric interfaces. I mean, and even some of the control plane components, as you can see in AMF, there are multiple network interfaces. It's not just about a single network interface, a service mesh, but our focus, what we feel, is just take those interfaces, standard Kubernetes interfaces, which are HTTP 2.0 based, bring in service mesh, solve the concrete problem, and then advance to the more complex problem with data plane or multiple network interfaces. And now taking it to the next level, this is even more exciting. We're looking carefully at the 5G architecture. So the 5G architecture is not just a single control plane. It's truly a distributed architecture, right? Where essentially the 5G core can be distributed. A very popular use case is roaming, right? Correct. So, so basically, there are some components of the control plane here on the left side, right, and some on the right side, correct. So, and then your data plane is right on the left side, where basically you want to examine the data traffic and shunt it out. So here, what is interesting is we talked about this multi-cluster service mesh. That's where this gets very interesting. We start off with the 5G core control plane, single service mesh. And now look at this, the beauty of this. So now you have, this is one Kubernetes cluster, and this can be another Kubernetes cluster, and you interconnect them, right, using your multi-cluster service mesh, which you talked about before. That's sort of the progression you want to go to. Start small with a single Kubernetes cluster, single service mesh, and advance here. And this is truly, we feel, at this point, we are providing multi-cluster solution which can work across operators, right? Because this is really a roaming scenario where this is probably part of one operator, this is probably part of another operator. And yeah, and basically, Istio service mesh, or sorry, any service mesh, I don't want to just mention the word Istio, all service meshes are all HTTP 2.0 based, focused on L7, and it's a perfect problem space. And both are completely from 3G, both these pictures from 3GPP, So all I did was highlight the relevant components and how they map out, right? So, oh, sorry, I should wait. Any questions on these 5G core? We're almost closing. Excellent. So if not, so the last slide, I'd like to close. So in ONAP, I'm leading the Edge coordinator efforts. So there are two key projects I'd like to talk about. The Onap the K8s, which is helping delivering this vision we talked about. And there are other aspects, but I wanted to sort of highlight the key ones. We talked about multi-cloud orchestrator, then also the service coupling, the service mesh. And our goal is to start small with a single cluster, but truly deliver a multi-cluster solution, multi-K8s cluster solution. There is also a closely related effort, the ICN blueprint and Akraino, which I'd like to point out, where essentially it's an integration testing effort, but taking the Onap the K8s and other relevant components and putting it all together, right? And thank you all for listening. I'm looking forward to participation in ONAP and Akraino and all edge-related activities. We are doing is sort of seeing what is the right spot for also advancing edge, especially the cloud native. We've been talking to the CNCF, and also to LF Edge. We're looking at the right sweet spot. There seem to be some sort of no concrete point emerging yet, because enterprises seem more interested in going to CNCF versus service providers coming to LF Edge, but it's still evolving. It's a new area. It's a great area to work on. Thank you so much for listening. Any other questions? We have some time, I think.